So the question here is derive the Fermi level position in an intrinsic semiconductor in terms of EC, EV and effective masses of electron as a Mn star and hole as a Mp star full stop. Hence calculate the position of the intrinsic Fermi level with respect to the center of the band gap in silicon at T is equal to 300 degree Kelvin full stop. Given that Mn star is equal to 1.08 times of M naught and Mp star is equal to 0.56 times of M naught full stop. Here M naught is rest mass of the electron full stop. And this is the question they had asked for engineering services exam in the mains exam for electronic and telecommunication from the subject of EDC for 10 marks. So here there is two part in this question. In the first part they are asking about that to derive the expression for Fermi energy level in intrinsic semiconductor, and as a second part of the question they are asking that to find out the intrinsic Fermi level with respect to the center of the band gap in silicon at T is equal to 300 degree Kelvin. So first of all we'll discuss about the first part of this question, how to derive this EFI, that is called intrinsic Fermi level for the intrinsic semiconductor. So as we know that the condition for an intrinsic semiconductor is the concentration of electron and the concentration of hole must be same, and that should be equal to Ni. So here that I had taken as equation number 1, and we can represent this N naught is equal to Ni in terms of EFI, and this can be written here as a N naught is called the electron concentration at thermal equilibrium, which is equal to Ni is equal to Nc exponential under bracket minus Ec minus EFI by kT. And let's see this as equation number 2. And now for this P naught is the concentration of hole at thermal equilibrium is equal to Ni is equal to Nb exponential under bracket minus EFI minus EV by kT. Let's say this as equation number 3. Now we need to equate this N naught and P naught from this equation 1. We can equate this, so we can write this Nv exponential minus of under bracket EFI minus EV divided by kT is equal to Nc exponential under bracket minus Ec minus EFI by kT. So by solving this equation we can find out this ratio as Nv by Nc is equal to exponential of under bracket minus Ec plus EFI minus EV by kT. And now we need to take this natural logarithm on both the sides. So taking natural logarithm on both the sides, this we can write it here, this EFI and this EFI will become 2 EFI. So we can write it here as a 2 EFI minus this is EC and this is EV with the minus sign. So if you take minus as outside, then this can be written as a EC plus EV is equal to kT ln of NV by NC. NV by NC. So now here this can be written as a EFI is equal to as a EC plus EV divided by 2 plus kT by 2 into ln NV by NC. NV by NC. So here this EC plus EV by 2 is called as a E mid gap, or this can be called here as a E mid gap, or this can be called as center of the band gap. So this I am saying here as a E mid gap, and this kT by 2, so here we need to represent this in terms of electron volt. So to represent this into electron volt, this kT, like here we can write kT by Q, then here we need to write as a E. So this kT by Q is called Vt as a thermal equivalent voltage whose unit is volt. So this can be representing now as a EV. So this kT is having the unit of joule. So to change this into electron volt, we need to divide this by Q. So now this can be written here as a E mid gap. This can be written here as a E mid gap plus kT by Q will become Vt by 2 into ln NV by NC. but we need to represent this EFI in terms of their effective mass as a MP star and Mn star. So now we can substitute here the value of NV and NC. So as we know that this NC is given here as a 2 into 2 pi Mn star KT divided by H square raised to 3 by 2, and this NV is given as 2 and under bracket 2 pi MP star KT divided by H square raised to 3 by 2. So now we need to substitute like let's say this as a question number 4. So in this equation number 4, we need to substitute the value of NC and NV. So we will get it here as a this EFI is equal to E mid gap plus, this can be written like whenever you will substitute this NV and NC value in this equation number 4, then this 3 by 2 will be multiplying with this VT by 2, with this VT by 2. So this will become here 3 VT by 4 into ln MP star divided by Mn star. So they had asked to find out the position of EFI or find out the expression of EFI in terms of MP star and Mn star. So this is the expression what we got. So this is here the expression for this EFI. Now if you'll observe this, mostly many times like students are having the misconception that this EFI for the intrinsic semiconductor is lying at the center of the band gap. So this we can say it here, this E mid gap we can say it here as a E center of gap. Center of gap. So most of the times students are saying that this EFI or for the intrinsic semiconductor Fermi energy level lies at the center of the band gap. That is not precisely correct here. The reason behind that, this term is extra here. So this can be EFI is equal to E mid gap only if the temperature is 0, because this VT depends upon the temperature. So if T is equal to 0, by that time this term will become 0 entirely, so that this EFI is equal to E mid gap. Now in the next case, if MP star and Mn star both the values are same, it means if the effective mass of hole and effective mass of electron both is same, in that case this ratio will become here 1 and ln of 1 will become here 0. In that case also this EFI is lying to E mid gap. Otherwise, if this condition is not there, then this will not lie, EFI is not lying at the E mid gap. It may be going upward, it may be going downward, as per the value depends upon this MP star and Mn star as well as their temperature. So as the second part of the question, it has given their MP star value and Mn star value. So there we need to find out this EFI position with respect to E mid gap. So now we need to find out here. So this is the energy band diagram. This is the energy band diagram for intrinsic semiconductor. For intrinsic semiconductor. So for the reference, I am taking this at the center point. So this is here as a EG. This entire gap is called here EG. So at EG by 2, that is called, this is called E mid gap, which is exactly the average of these two values. So this is giving here as a EC plus EV by 2. So this is for the reference I am taking, but EFI, it may be lying at this place, or it may be going down to this, or it may be going up to this, depending upon the condition. So as per the condition given in the question, that their MP star value and Mn star value it has given, if you'll see that in the question part it has given the value here. So this Mn star is having 1.08 times of m naught, and mp star is equal to 0.56 times of this m naught, where m naught is the rest mass of the electron. So we need to substitute this mn star value and mp star value in the equation derived as a first part of the question. Then we will get the position of EFI with respect to the center of the band gap. So now we need to substitute the value of this in this equation. So let's say in this equation we need to substitute this value. So let's say this as equation number 5. So in this equation number 5 we need to substitute the value here. So we will get it like EFI is equal to E mid gap plus 3 by 4, and this Vt at room temperature, their precise value is 0.0259 into ln. This mp star is 0.56 times of m naught divided by this mn star is 1.08 times of m naught. So this m naught gets cancelled, and after calculating this we will get it here E mid gap. And if you see that this ratio 0.56 divided by 1.08, so this ratio is less than 1, it means their ln will become negative. Multiplying to these terms here, so this is giving as a E mid gap minus 0.012 electron volt. What it is saying here? This is saying that this EFI value, this negative sign is saying that this EFI value will lies below of this E mid gap by the value of 0.012 electron volt. So let's say it is lying somewhere at this point. This is called here as a EFI, and this gap is here as a 0.012 electron volt. So here, so as per the second part of the question, they had asked about that the position of this EFI with respect to E mid gap, then their magnitude will become 0.012 electron volt, or we can say that this EFI lies below of this E mid gap by the magnitude of 0.012 electron volt. So their numerical values will be 0.012 electron volt, and as per the sign convention we can say that it is lying below of this E mid gap. This minus sign is saying that it lies below of this E mid gap by the amount of 0.012 electron volt. So the answer for the second part will become 0.012 electron volt below this E mid gap. So the numerical values for this one is 0.012 electron volt. And now by this way, this is the end of the solution for this question.